capability is, in a sense, a national competitive asset. There are 6 labs involved in this at this moment. We need to start to think about what the next 10 to 15 years will be looking like. That's why I'm super optimistic that this will generate some exciting systems.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey, Shaheen, good to be with you.
Great to be with you.
Okay, so today we have a special guest, a longtime HPC community luminary, Horst Simon. He presently is special advisor to the lab director at Berkeley National Lab, and he's also on assignment to the Department of Energy Office of Science, specifically the Office of Advanced Scientific Computing Research. Horst, welcome.
Good afternoon. I'm happy to be here and talking with you.
Okay, great. Specifically, we wanted to talk about the RFI issued this week by DOE that discusses their strategic thinking about next generation leadership computing, supercomputing systems. This within a month of Frontier really having seized the spotlight by achieving the exascale performance milestone and also being named the number one supercomputer in the world. So having done that, now it's time to move on to the next thing, I guess.
That's exactly right. And I think that's where we're at, that the exascale project has, the exascale computing project, to be precise, still has about a year to go and has made great progress. But we also have exascale systems now. We have, of course, Frontier installed and being the number one system, and we still have Aurora and El Capitan to follow in the next year. So within a year or so, the exascale project is coming to full fruition. And it's important to keep in mind that the first exascale conversations happened in 2006, 2007, 2008, so quite a while ago. And so we have been working on this for many reasons, for over 15 years. And so we need to start to think about what the next 10 to 15 years will be looking like.
Horst, the document that was published is a request for information, RFI.
Yes.
There's also the common request for a proposal. There used to be a request for a quote. So these RFI, RFP, RFQ, all these other RFs, would you explain the process to do these procurements?
Yes. So the RFI is a request for information, and this is from the community, and it's coming from the national labs that will host the supercomputing systems in the next decade. It's a question on to the large community of vendors that provide not just high-end systems, but that provide all technology that might fit into the next generation ecosystem. And that's why we're asking also for advanced computing ecosystem information. And so the reason this is there is that it will give us an outlook on what is possible, what can be expected, and will be used to formulate for us a strategy on what we think. And by we, I mean there are 6 labs involved in this at this moment, what we can plan to do. And so this is important to get this information in, that we don't set unrealistic goals. So we could say we want a 100 exaflop system by 2026 in 4 years. And the answer that we would get back in terms of if we ask for this in a proposal would be at a price point that we couldn't afford or at a power consumption point that we could never manage. So the request for information is out there for us to realistically scale our plans and then push hard where we think there is some opportunity to push. That's one. So it is for us as an input to a planning document, and as the next step with the information that is coming in, we will establish a plan. And if you look back again over the exascale time, there were some early planning documents that were available in around 2010, which said what systems we would like to acquire by 2016. I believe there was a 2016 exascale prototype and then 2020 prototype. Of course, the time scale was not met, But that is what will happen with the RFI input. It will lead to a plan. And after this plan is established, then the individual labs will issue their RFPs for the next generation systems. And these will be based on the plan. So the plan will be our guiding document.
I see.
Also, one more point here, which is very important for the RFI, is that the RFI is an open process, and so it's a conversation that we like to engage the vendor community with, so that there will be also feedback provided. So feedback can be in two general forms. One is, this is never going to happen, or you guys must be crazy. And the other feedback would be, you haven't thought about this great and wonderful technology that we have here, that we haven't talked with anybody yet, but we really would like you to know there's something coming in 2 or 3 years that you should really take into consideration. And of course, things like this would be under non-disclosure, but it is an invitation to a dialogue.
I was just going to ask if the responses are kept confidential, and they seem to be, so that gives them freedom to really share things.
Yes, so the responses will be confidential. We assume that they will be all business sensitive for the vendors, but it gives, under NDA, us the opportunity to have an open conversation with vendors in terms of what we would like to see and where we, as I said, we might see surprises of what's out there.
The piece that I wrote this week, what I led with wasn't so much the power performance increases that DOE is looking for, which is 5 to 10 times faster.
Yes.
Which seems to be kind of in a normal cadence of one generation
Yes.
leadership systems to the next. But that you're looking at a different approach, moving away from the phrase is monolithic acquisitions and moving toward more modular, more rapid upgrade cycle. There's also a call for urging the reimagining of systems architecture within this notion of the ACE, the advanced computing ecosystem.
Yes.
I kind of have these nebulous notions forming that this could almost be like a supercomputing backplane of very much shared resources, and pieces of it are under continual innovation and upgrade. Notions like that.
That's a good model.
Okay.
Yeah, but I was going to say there are two things how this is different from a monolithic procurement, and I think it's different in two ways, both in the time direction but also in the capability direction. In time direction, if you go back, you see that we were going through the exascale procurements that had certain systems, they had milestones and deliverables with particular solutions that then were fixed in time. And this was actually not the optimal way of going about. For example, that technology has been changing, and we've seen this in several of the procurements in the history. That was what was envisioned in 2016 as an exascale system is not exactly what we're getting now in 2022 or 2023 as exascale systems. So there always has been a change in technology over time. So fixing a point in time and fixing the technology is not how things actually happen. So we need to have more flexibility in terms of upgrading system, taking possibly old systems and adding technology, making them faster, providing more memory, providing more bandwidth if there's new technology coming along, so that we would have over time a more flexible upgrade path. And this is actually mentioned specifically also in the RFI for vendors to comment about what they would suggest as models of how to be more flexible over the lifetime of a system to provide augmentations, upgrades in capability. The second direction is that it is an environment, and if you read this carefully, there is the flexibility to add into this environment AI accelerators, hybrid quantum systems, if these become available. And so we would like to understand how these different new computing technologies could be brought into this environment and could work together. On this, I would like to say that we're probably coming through this next couple of years into a very exciting time, because in one hand, one of the lessons I took away from ISC was that top 500 trade line prediction was that we won't get a 10 exaflop system before 2030, which seems to be disappointing.
Mm.
But I think that we will see over the next 4 to 8 years a significant enhancement of the science that will come out of big systems through basically these accelerations. So, for example, if we can add some AI acceleration and then run surrogate models on an AI accelerator that can overall accelerate the science output, as it has been already demonstrated in some cases. And so we expect in particular through the integration of AI, both in terms of AI tools and technology, but AI acceleration into the system to get surprising new results in new science. And the same can be probably said about quantum systems, although I don't think that the quantum systems are as close to being integrated into a hybrid fashion as AI acceleration is.
RFI also mentions the word ecosystem rather than just system.
Yes.
What is the thought process behind adding echo to the word?
It is because in the last couple of years, all the high-end facilities, in particular in the Office of Science, have formed close collaboration. NERSC, for example, has championed the concept of a super facility, which would be a tight integration of the high-end scientific facilities that the Office of Science is supporting. That is for light sources, the material science for nanocenters, microscopy centers, maybe manufacturing capability, and the high-energy physics experiments. All these are sources of data, and the use of these scientific facilities will be accelerated by tight integration with computing.
Mm-hmm.
So we've done some, NERSC has done a prototype of connecting with the LINAC coherent light source, LCLS, at SLAC, and used an ESNet high bandwidth connection, which was sort of a Bay Area highway, and got data from the LCLS straight to NERSC for processing, and this was just the first prototype. And so the light sources all have recognized that they need much more data processing and need also a place to get very quick throughput on the data. And this will be done through an integration of the networking and the HPC data analysis capabilities and the storage capabilities.
I saw the wide area interconnect.
Yeah.
High volume, high bandwidth, long distance use case.
Yes.
Which seems really interesting and a completely new muscle, so to say.
Yes, it is.
So, okay, that's wonderful. That's really great to hear. So part of that really is the recognition that we are looking at, by definition, a geographically dispersed data fabric that needs to match a compute facility that is also spread around by necessity. Am I reading that right?
Yes, that's correct. And I think that would be a grand vision to have all these capabilities tied together and from a scientific user point of view being easily usable and interchangeably as the applications change being usable. Yes.
And that feeds into this modular idea to an extent, but certainly shared resources idea. I guess one analogy that came to mind for me is this a valid thought that we're moving away from, say, Apollo class spacecraft and more toward the space shuttle idea, reusable and also incrementally bringing innovation and enhancements?
So yes, you could say that, even though I always don't like the space shuttle analogy because we had two big accidents. So
aside from that, yes. I'm also wondering, we've seen the dwindling number of systems makers that are willing or even able to build these, what's called in the document, monolithic acquisitions.
Yes.
And I'm wondering if this idea might also be a way, if there are implications for bringing more vendors into the picture by almost creating the leadership class market that's more accessible to more companies.
Yes. Part of the thinking here is to tell the vendor community that exascale is not the end of the line, but we will continue. And of course, we need to continue maintaining the application and software investments that were made for exascale. But it's not just more of the same, but there will be opportunities to come in with new ideas and look at high performance computing in this integrated ecosystem point of view. So we hope that this will be exciting for vendors. And we've heard this in the last month and a half from many vendors that they are very interested in participating in this. And yes, we hope that we can create a market.
One thing I found interesting, and again, here's the difference between an RFP and an RFI, is the way the agency was not adamant at all in how they proposed their ideas. They are just at this point ideas, and they even invited pushback. We invite responses to include perceived benefits and or disadvantages of this modular upgrade approach. I thought that was quite interesting.
Yes. Yes.
Yeah, I love that aspect of it, that it is really
Yeah.
come have a chat with us and tell us what we are thinking wrong, what we're doing well, and what we are not thinking about.
So maybe I can comment on this as follows, is that we invited all the vendors who wanted to give us a preview of their planned RFI response. And so we had of the order of 30 or more 1-hour meetings in the last 6 to 8 weeks. And I thought this was one of the most enjoyable things in my job currently.
Yes.
To hear all this technology being discussed. And in these conversations, I think through questions, we can direct vendors in certain ways. And so I think that was a very good process. And as I said, I also heard a number of new things that I wasn't aware of. And that's why I'm super optimistic that this will generate some exciting systems.
I wish you could continue on with more details about what those super exciting things are, but I'm sure you can't at this point.
Well, let me just say it generally. There are developments from basically semiconductor basic technology research that will be seen probably in 3 to 4 years to all the technology pieces that are out there. So if you put it all together, it's a very intriguing future.
What about software? I noticed last week at the conference at Oak Ridge, there was a mention that El Capitan was going to use the TOS stack and not the vendor-provided stack for the first time. And I know, of course, the Exascale project had a very significant software component.
Yes.
How do you see that evolving?
That's an important question, and this is currently being discussed. We have, in a sense, a white paper which has been put together by the Exascale software community, how to continue this work and how DOE labs could maintain this Exascale software stack in the future. And that's a possibility that this might be happening.
Now, with the ecosystem also comes the notion of federated computing and what we used to call global grid beyond the campus grid. Is the software for that part of what the labs are creating or looking for the outside vendors to create or open source projects that might happen?
That I don't know yet. That's sort of a question where we hopefully get some responses back and saying what the vendors are thinking. But I think in terms of this integrated infrastructure, that's probably something that we will have to do at the labs, because the interface with the scientific user facility is very unique, and each facility has a unique set of capabilities. So that's probably something that we need to develop in-house.
Another question is, why not just go to cloud and be done with it?
Oh, yeah, of course.
Pay as you go, annual budget works, etc.
Well, we asked for cloud vendors to give us their perspective on this. And I think there is a strong argument that has nothing to do with technology directly against the cloud. And this is that the national labs now, thanks to Exascale, have built up a extremely strong intellectual capability in computing. And the capability is, in a sense, a national competitive asset. So I would put this in the same category as the national labs in the nuclear age built up the nuclear weapons capability, and was built on the intellectual assets of staff that was helping. Most of the people who have been in the Exascale project or joined the national labs over the last decade or so did this because of the excitement to work on some real leading edge technology and doing some exciting new work. Now, if we simply go to cloud, then there's no good reason for smart people to stay at the labs, because then they will go to the hyperscalers because that's where the excitement is. And so The point of doing this on site, or to use the term on premises, is because we need to maintain the intellectual capability in computational science as a national capability.
Interesting.
Very much. In our last episode, we talked about the importance of the mission for these activities that goes well beyond a lot of other considerations.
Yes.
And in agreement with you, I think maintaining the mission is really what makes these so exciting and what causes people to be passionate about.
Right, exactly.
By the same token, Horst, we talked a little bit about creating a market, if you will, partially through this advanced computing ecosystem notion. And I'm wondering if there could be greater potential for supercomputing class technologies that are built for the ACE, working their way into the broader HPC advanced computing markets at a more rapid pace.
Well, that's always our expectation, that what is being done in the high end, what is done now in exascale systems, will eventually find its way into the commercial market. And we've seen this happening many times in the history of HPC. And so are you implying that this would be faster if we're going through the cloud?
No, through the advanced computing ecosystem.
Yeah, I think that is definitely a goal, that we would have technology that will find its way into the broader HPC environment, industrial user.
Horst, I want to bring it back to the multidisciplinary, multi-physics, federated computing, and that all fits with the ecosystem. But I also remember a few years ago, you personally were working on bringing multiple different places together, whether it was the computational science activity at UC Berkeley, which I know you guys led in the early days, and I remember Gene Golub doing it at Stanford in the early days.
Yep.
And then the DOE, DOD, NIH, NASA, bring them all together. I remember that we did the NAS parallel benchmarks even before that. So I think the whole multidisciplinary thing is something that you've been very intimate with.
Yes.
I would like to talk a little bit about that, but maybe to provide an ingredient to start it, do you envision this ecosystem to specialize in specific use cases or capabilities? Like, here's our quantum preferred site, and here's our large memory preferred site, and somehow those probably would be matched with whatever instruments happen to be nearby that are spewing out the data. I'm trying to have that image in mind, but I can't help but think that this is a very multidisciplinary workflow thing that we are moving towards. Is that right?
Yeah, that's a good speculation, but I would put it at this point in this category of speculation. That's where we are going in this process, is after we hear and read the feedback to the RFI, then we may come up with a plan like this, but that's, you should ask me a year from now again.
All right.
Okay.
To use another word that I think has been intimately part of your work, I think this is unstructured domain decomposition right there.
Yeah, that's a good point. Yeah.
All right.
Gene, anything else?
No, thank you. This was wonderful, and I'm grateful to have the opportunity.
Yeah, that was very informative.
Yeah, I very much enjoyed it. I'd like to thank you for leading this conversation, touching all the right points. And so I'm very much looking forward to listening to the podcast.
Brilliant.
Okay.
Thanks.
Very good. Well, thanks so much, Horst. And thank you, Shaheen.
Thank you. Take care.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.